Alrighty, GHOA number 2.
We've kind of already
been going over the extension problems
from
or the preparation
stuff. Preparation problems. Sorry, extension problems. Extension problems are right here, so we'll kind of go over these now. Should be fun.
Number 1, find the vertex of the following quadratic equation by completing the square. Also identify the x and y intercepts, domain and range, symmetry, and provide a graph. Holy cow.
So
f of x is 3 squared minus 4x plus 8. I want to complete the square.
So we can't factor out the 3. 2 on the preparation.
Well, we could. We could just do 3 times x squared minus 4 thirds x. Right?
Yeah.
And then plus what's half of 4 thirds? 8 thirds?
Yeah.
No, 2 thirds. 2 thirds. 2 thirds squared is 4/9.
Yeah.
Minus 4. Is there a key for this? Yes.
Yeah.
That's good. So we're doing the like the guy did in the video where you complete the square, but you're balancing the equation. So you're doing it all on one side.
Plus 4/9 and then minus 4/9.
All in the equation, then you got plus 8. Hi, buddy. So.
Okay, let's laptop.
And then you wanna. That's okay. My wife.
Good answer.
To get negative 4/9 out of the parentheses.
So multiplying by 3.
Yeah, so
12/9, which is
3. This would be 27/9 times.
Yeah.
No, what?
Just 12/9.
Yeah.
4 thirds.
I was trying to find a common denominator.
4 thirds. 12/9 is 4 thirds.
Yeah.
3 x squared minus 4 thirds x plus 4/9. Then we got 4 thirds minus 4 thirds plus 8.
So 3x squared minus 4 thirds x plus 4/9 plus minus, right? Minus 4 thirds plus 8.
Yeah. So that would equal 7 2/3. No, 6 2/3. 20 thirds.
Yeah. Minus 20 thirds, and that factor would just be 3 times x minus 2 thirds squared.
Wait. Yeah.
Minus 20 thirds.
How did you get to subtract or like negative?
What?
How did you get to negative 20 thirds?
So you have the negative 4/3 plus 8 outside of parentheses.
Yeah.
Let's find the common denominator. So 8 is 24 over 3.
Okay.
It's plus 20 thirds.
And like 20 plus negative 4 is, or 24 plus negative 4 is 20 over 3.
So then it's a positive.
Yeah.
Oh, I have a negative. My bad. Plus 20 thirds. I'm sorry. Thank you. So I make little mistakes like that and I get everything wrong. And I think then you could multiply everything by 3. I don't know. Wait, you'd have to do that with another second.
So what's the simplified? 3 is x minus 2/3. Okay, yeah.
3 times x minus 2/3 squared plus 20 thirds.
That's what I got.
Okay.
So then the vertex is
2/3.
negative 2/3.
Is it negative?
No, positive.
Is it squared? Like do the opposite?
No, because
Just the form. It's always x minus.
It's minus the
Oh, yeah.
extra. If it was positive, it would be negative.
Yeah. I get it.
Good thing you know what we're talking about.
And then is it minus 20 thirds for the k?
Yeah. No, I think it's just
No.
20
Is it
thirds.
just 20 thirds? Okay.
K is just like, if it's a minus whatever, K is just the negative whatever, you include whatever sign is in front.
Okay.
But H, you do the opposite.
Gotcha.
Let's plug 0 in for 1.
So we got 20 thirds equals 3 x minus 2 thirds squared. We divide by 3. So 20 thirds. Divided by 3, that's just times 1/3, right?
Yeah. Divide by 3.
So we got 29.
Wait. If we divide one side by 3, then we multiply the other side by 3, right?
Multiply by 1/3.
Multiply by 1/3. When you
Because
divide fractions, you just flip it and then multiply it.
And you do the reciprocal of the fraction. So if the fraction is 3/1, and you're dividing a fraction, you multiply by the reciprocal.
Oh. Yeah. Okay.
So it's 29ths.
It's negative 29, right? Because we subtracted it from the other side.
Oh, yeah, that's correct.
Equals x minus 2/3 squared. So
So then we do the square root. So we got plus or minus I square root 20 over 9. And then add 2/3. 2/3 plus or minus I square root 20 over 9, right?
Yeah. But can I take out the 9 and make it like 1/3? Or
because the square root of negative 20 over the square root, or the square root of negative 20 over 9 is the same thing as the square root of negative 20 divided by the square root of 9, right? So it'd be x squared plus or minus, or x equals, isn't it, 2/3 plus or minus.
no, I'm doing it wrong. I'm looking at
I think you can do
the.
that.
I mean, you can, but
Do they not want that? Because it would be like
they're
I root 20
yeah,
over 3.
yeah. I was also talking about also doing it to the denominator, so taking out the 20.
Oh.
Because you can do 4 by 5, and 4 is a perfect square.
Would you do that then?
Well, that's what I would do, but that's not what the answer's saying.
So the answer is plus or minus I times the square root of 28 over 3.
Yeah.
2/3 plus or minus all that.
At least we did it.
We did it, right?
Right. X-intercept. Y-intercept is just X0, just 8. So the main and range.
8. Sorry. Slow.
To graph this thing, it'd be at 8.
Wait, the domain. The domain range, right?
Yeah, that's what I'm trying to figure out.
Well,
Trying to graph it so then I can see the domain and range.
I do graph it, I don't know that like it's going to just be obvious. Like the range is where I get tricky. Because it's just one of those random functions, so you can just anything squared in the function is going to be quadrant.
Or the y-intercept is 8. Wouldn't it just be all y is up to 8? Is it from 8 up or is it going 8 down? Okay. It's going 8 up, then why do we have x-intercepts?
Because it still crosses. That's one. It still crosses S's at a point.
On the x-axis? If the y-intercept's 8, it's probably going up.
Yeah.
That's where I'm confused.
Anything, right?
Right.
We're trying to figure out the range.
Yeah.
No, he's just trying to understand why do we have an x-intercept if we're going to be starting, if the y-intercept is at 0.
It's a parabola.
And it's a parabola and it's going up.
That doesn't make any sense to me.
That is it. But it has a negative x-intercept in the.
It does have an imaginary number, so it could be.
Let's see.
I guess we got a video recording right now.
Oh, you missed.
Yeah, that doesn't have an x-intercept.
Yeah.
Because it's an imaginary number.
We're just imagining.
But algebraically, I guess it does. It's some strange alternate universe.
Alright, so range equals 8 to positive infinity.
Sorry.
Range equals 8 and infinity.
Would it be strict 8 or just open 8?
No, I mean, whoa there. Okay. No, because taking the vertex form
the
of it and
vertex.
everything.
It'd be like
20
20
over
thirds.
That's right.
Yeah.
That's right.
Infinity.
Yeah.
But is it actually at 20 thirds? Or do we have to use that weird bracket thing?
They didn't use the weird one,
It is
so looks like it's closed.
20 thirds to infinity.
That's my understanding of it.
Yeah, you're right.
The only thing I don't get is the axis of symmetry.
There's no symmetry.
It's a pattern.
No, but it's not over the x-axis. So
Right. So, but apparently you can make a certain x point be like the axis of symmetry. So, like, it can be like an axis of symmetry of 2.
It's just like
the
a,
axis of symmetry
Yeah,
is
it's
the
just
vertex, then, wherever the vertex is.
yeah, we're at the x and the vertex.
The axis of symmetry is 2 thirds.
Yeah, this is where you made symmetrical.
But according to just like the normal x and y, it's not symmetrical.
Okay. Well, now that makes sense.
All right. That was fun. So we're going to provide a graph. Wait, did we even print this thing off? So this one could be described. Wait, this isn't the quiz. Okay. We're good.
It's fine.
We're good.
So we're just trying to run through these so we can take the quiz.
Yeah.
Yeah.
These are a lot longer group meetings than I had when I was doing the statistics class. That class is like put everything into Excel and then you're done. It's like 10-minute meetings. Okay.
Okay, there we go. Number 2, we're at number 2, right?
Yeah.
Let's straight upward with an initial velocity of 80 feet per second. And the maximum number football. So it's a negative travel for a vertex. So it's basically what this graph would be. Turn it up.
Yep. So it's, yeah, so if you look at it,
But we don't
Well,
really
the
care
trajectory of the ball.
X, do we?
It's
We
like-
just care about how high the y is.
yeah, we don't really care how long it's because x is t. T is just the time it's in the air.
So we just need to complete the square in front of vertex. Right? That's
Yeah.
good. And we can probably divide volume by something.
No, there's an easier way to do these problems because we did it. I did a lot of these in college algebra. They're actually like super easy. I just can't remember how to do them.
Oh, really?
Yeah.
If you guys haven't even my math level, there's my math level for this week, right?
Yeah.
And an exam.
And an exam.
Yeah, I got to do some of that because I was doing it all day last Saturday.
I didn't get to like much of my math on the first week, and so I finally caught up and everything, but did nothing this week. So I still have all of this week.
I guess that's true. I didn't do 2 weeks worth last week. So this one, we can factor out 16. Negative
80
16.
over 16.
That's negative 5.
Okay.
16 t squared minus 5t. Half of 5 is 5, negative 5 halves squared. Negative 25 halves.
I forgot to divide by.
There's 20, yeah, it's plus 25 halves.
No, it's 25 fourths.
Minus
25 fourths.
fourths.
Because he squared it. Because he squared it.
That's right. That's right. And so,
There's an easier way to do these though.
oh yeah,
Sure. Sure.
I just can't remember what it was. I have to find my old math notebooks. Yeah.
So 16 times 25.
And so we go, yeah, 16. Where am I doing calculator? That'd be nice to have right now.
How have you been thinking this?
Huh?
Negative 25 over 4 times 16.
Oh yeah, because you just,
Negative 16.
16 times 25 is 400.
it's negative 4 times 25. It's,
Wait, what?
What?
so negative 16 times 25 fours, you can cross multiply that because 4 goes into 16. So that makes it negative 4, not 1.
So you just multiply it across?
You can't make it
16
easier.
over 1. This is easy?
Yeah, well, just go negative 16 over 1 times 25 fourths. 4 goes in 16. So it makes that negative 4 and then 25 over 1. It's
Oh,
just
yeah, you can.
negative 100.
Okay. That's what I was going to get, I guess. Yeah, that makes sense. Because 16 times 12, or 16 times 24 is 400 over 4.
Yeah.
So positive 100, because they're both negative.
Yeah.
And add that to 12, right?
Yep. So we got negative 16 t squared minus 5t plus 25 fourths plus 112.
So it would be negative 16 times
T
minus 5 halves squared plus 112. So the vertex is
5 halves and 112. Let's see. On the maximum height above ground level. So he already started 12 feet above the ground.
80 feet per second.
Above ground level, I guess. So yeah, so it's 112 feet.
That's cool. Real life application. I don't know why I care so much about high above go.
And then what times ball hit the ground? So that's just, remember, height equals 0. So y equals 0 on that.
Time is the t, right?
Time is t,
X
yes.
value.
At what point is h 0? H is height. When does it hit the ground? So g equals what at h equals 0?
Oh, so you just plug 0 in for the y or the h, the t of h. Or the
It's just finding the x-intercept. That's what it is. At negative 112. $16 does go into 112. That's nice.
Probably 10 numbers? 10 times, no.
7.
Sorry, 7.
7 equals t minus 5 halves squared. So we got square root of 7.
And then
5 halves plus 7.
So 5
Say
plus
5.15.
or minus square root of 7.
It's just plus. Yeah, because when there's an imaginary number, then it's plus or minus. On this one, there's no imaginary number, so it's just plus.
So that's pretty simple. Yeah. 5 seconds plus the square root of 7 seconds.
5.15.
5.15.
Mm-hmm.
Using the rational roots. Sorry, I said naughty word. Rational roots theorem.
So that's just what, 6 over 2?
1, 2, 3, 6 over 2. So 1 plus or minus 1, 2, 3, 6.
You were hungry?
Yeah.
Oh.
And then number 2 would be
1, 2.
1/2. And then 1, 2, 3. So we have those.
What's the first step?
So 6 is P,
Okay.
and 2 is Q. The factors of 6 are 1, 2, 3, and 6. And the factors of 2 are 1 and 2. Right?
Yeah.
The factors of 6 are 1, 2, 3, and 6 over the factors of 2, 1, and 2. So we got 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Plus or minus.
Yeah.
And then plus or minus 1 over 2. But then the 2 over 2, I guess the 3 over 2 would be.
This is just like the least common denominator things, right?
I don't know. It is 3 over 2. Is 2 over 2 would just be 1 again. And 6 over 2 would just be 3 again. So
So we got 1/2.
3 halves.
1. 3 halves. 2.
2, 3, and 6.
And what? Just 3 and 6.
2, 3, and 6, yeah.
Deal.
Did you get that?
Yeah, so in that, so we got 6 and 2 is P and Q.
Mhm.
So you got all the factors of 6 and all the factors of 2.
Okay.
And then those are the fractions. So we got 1 is a fraction, then we got 1/2, we got 2, we got 3 halves, we got 3 and 6, and then 6/2 is just 3.
Right,
So
right, yeah. 6. Well, I just said it the other way around than you did, but yeah.
yeah.
Okay. Okay, so then how do we find the x-intercept with that?
Are those just 6 intercepts?
Using the Raphson theorem, find the x-intercepts of the given polynomials. And then the answer is only 3.
3. Son of a gun. I don't know.
I guess you would close all of them in. Or
Find them.
something.
And see which one comes out to 0.
Yeah, so you can just do synthetic division.
What's
Still haven't
that?
gotten that far. So
So
synthetic division helps to like be able to like take these polynomials and be able to divide and be able to factor out like a lot of stuff. A lot more simple and be able to.
Okay.
It's fun to do. I don't remember how to do it. I remember it was fun, but I just need to refresh my memory on like the steps to do it, and then it'll be fun again.
So what are you doing?
this stuff right here. You take all the what do you call those? The numbers before x. Yeah, those guys. And you put them across this way, and right here you just plug in numbers we got, like 1/2, 1, and then you multiply it, get that, times that, add it, add that, until you can get a 0 at the very end. Once you get a 0, it's actually better. Yeah. If I can figure it out, I'll show you how I did it.
That was in the book.
Yeah.
In chapter 3.
Yes.
Mm-hmm.
This expression. Personal tastes are not like division. It's very, very, very. I prefer to use traditional algebra division. But I think you'll see that this has some advantages. It's gotta be one of these fraction ones. It's gotta be the first one.
What?
First 0's gotta be one of these fractions. Sucks.
The examples are in the book. It's exactly the same
What?
in the book. These problems that we're working on
Uh-huh.
are exactly the same in the book.
That's
And it
stupid.
explains everything. So the solution for A, the possible rational series of f of x, so that's the example 5a. Okay, yeah, we got that. Use the synthetic division to check which possible zero to see whether it's actually a zero. So try 1 first. Then we put 1 on the outside, and then
I don't.
I got -6 when I had 1 when I used 1. -6 was the very end.
Yeah, -6 is at the very end.
Yeah.
And your first one is, you should have 4 numbers at like the bottom of your.
Yeah, so I got 2, -1, -12, -6.
What?
And since the remainder is -6, 1 is not a zero of function.
Mm-hmm.
So keep on trying numbers from the list of possible rational zeros. 6 space will not show any more failures. So try 1/2.
How do you do it though?
I started to do 1/2 first, but I was like, oh, I hate fractions, so I'm doing whole numbers.
So it's just basically, so the top part of what I see is that you just take the quotients of like the equation.
So
And then how do you get like 2, -1, and then -6, or -12 under 6? And everything?
Yeah, so
How do you find those numbers out?
you go 1 times 2 is 2, 2 times 1 is 2, -3 plus 2 is -1, -1 times 1
Yeah.
is -1, -11 minus 1 is -12, -12 times 1 is -12.
Oh,
6.
okay. Yeah.
You just keep coming back to that one you're using.
That's so annoying. Okay, so like, so here's 2. So you could,
Where did the 11 come from?
the 11 came from the original.
These?
The original problem. So like, you see
The
here
original
the
equation?
function. Yeah, so you have 2, the -3, the -11, and then the 6, and it's just all right there on the first row line.
2/3. The 2x to the third minus 3x squared minus 11x plus 6.
Yeah. So then you use all these
2,
proportions.
-3, -11, and 6.
Yeah.
Where do you put them?
So in the synthetic division, as we know, one of our options is 1. So then we put like 1 on the outside of the box. So right there, we put the 1 right there.
So I put all this other stuff?
Yeah, so then -3 and -11 and then 6. Those are the quotients in the equation. And so 1 is one of the possible answers.
Okay.
So then what he did is, well, 2 minus 0 is 2. So you just put 2 down at the bottom.
Where's the
At the bottom underneath the line.
Oh.
That's one of your answers, or well, not answers, but possibilities.
minus 0?
Yeah, so then 2 times 1 is 2, so then you put it underneath the -3. So then -3 minus 2 is -1. Right? Or is it -3 plus 2? It's -3 plus 2.
Okay.
And then -1 times 1 is -1, so then
-1 plus 11,
-12 times 1 is -12. So then -12 plus 6 is 6.
Okay, if you don't get 0 to n, then it's not one of them?
Yeah, if you don't get like any of the zeros or like nothing remaining, then it's not one of the answers.
Try 1/2.
1/2 is supposed to be 0?
Half is supposed to be 0. What'd you get?
0.
That's 0.
So 2, so
1/2 times 2 is
walk them
1.
through again.
Yeah.
2 minus 0 is 2.
No, it's 2 plus 0
2 plus 0
is 2.
1/2 times 2 is 1.
Yeah.
Plus 3.
-3. So 1 plus -3 is -2.
1/2 times -2 is -1. -12. 1/2 times -12. 6. 6 plus negative 6 is 0.
Yeah, he got it.
Where'd I go wrong? What's yours?
So on 2 plus 0 is 2.5 times 2.
Oh, yeah, I missed a step. That's why I did it wrong. Okay,
So then we just
We
keep
did-
going. We do all of them.
good. And then you just take the next
Negative.
ones.
Do you?
So you do it now?
Because you got plus or minus all of those. You have to do the negative.
So what you do next is you just take your next ones, the ones you had left over after the 0, you take those ones, and then you keep using your zeros all the way down. Keep using your numbers that you had left over. So I did it wrong. So take what you have left over.
But I didn't keep the leftovers from the first one for 1.
It's okay, you don't need those ones. You just need those ones. So you got 2.
Do I
Negative
write it
2.
up here?
No.
Like make a new
Yeah,
one?
you make a new one.
2, negative 2, negative 12, 0.
Yeah, you don't need to write the 0. And then you just do the same thing again with those same numbers.
Which
Like either 1 or 2 or 3. Just the zeros that you had.
Don't you want to go
Alrighty.
to the original equation?
So 1.
We already tried one, so try 2.
Oh, right, because we don't. 2 doesn't work, and we know 1/2 works. So then 3/2. Do the next one. 2 plus 0 is 2. 3/2 times 2.
Yeah, times 2
Is 30.
6/2, so 3, yeah.
1. 3/2 times 1 is 3/2. So 12 plus 3/2 is not 0. Or negative 12 plus 3/2 is not 0. It's negative 10.5. So if that doesn't work, what do?
You try a different
You
number.
use the same leftovers with the next number?
Yeah, you just use the original numbers. If it doesn't come out 0, you just start over.
Okay, so 2. Okay, so then you use those again. Because 3 is 1.
3 made a 0.
Yeah.
Okay, so yeah, then you just use
Then
those
you
other
use
2.
2 and 4.
Mm-hmm.
6 is all that's left. Nope. So it's
Use a negative 2 if you need to.
oh, you're supposed to do the negatives as well.
Yeah.
Gosh.
Or it's plus or minus.
Right.
All those. You try like negative 3, or you can try negative 2 or negative 1. Negative 2 works, doesn't it?
It does.
Negative 2 is another one.
And if that's then it's just 2. Do you use the leftovers after that?
I think it's just 2. Yeah.
So, in this example, what he's trying to do.
You're just trying to get it down to that.
Yeah, so like what he's explaining here is how this problem, we have like
Oh, it's just 0.
all these portions and everything. And so then the solution on the next page, you have the 1, 1, 15, negative 2. So these are like the zeros. So they went into one, and then got all those numbers, and all of these are the ones that were like it. So then they tried -4 for the ones, and then those are the numbers that they got. So then it is just canceling down and everything. I thought there was like a different setup and everything. But I mean, that's what Kevin's trying to explain. I'm trying to make it happen.
So
Yeah, so your leftover one, 2 times 0 is 0. So your last 0 would be 0.
So then there's that plus or minus imaginary the square root of 5. I think it's just because of that part right there. Yep. Crazy math.
It's fun,
What
right?
are you asking again?
I don't know. I just the last 0 on that is your last one. The last leftover number is 2. So your last 0 would be 0. 0 times 2 equals 0.
Right. So -2, 0. 1/2, 0. And 3, 0. Let's just do the group because I'm working 30 minutes.
Okay. You had 1/2? That's right. Where's that at?
We have to print it out, don't we?
Yeah.
That's a funny question. There's a group. The group leader will submit one copy of the group. Make sure to submit the group quiz as a single PDF document. You may only use your textbook notes and calculator on these problems. You may not use any outside resources, including the instrument tools or solution manuals. Remember that the purpose of the quiz is to see if you understand what you have learned. And will also tell you what you still need to study for the upcoming exam. Make sure to show your work in the neat and organized manner.
All right. I'll print that off real quick.
So, 1, find the x intercepts of the quadratic equation y equals ax squared plus bx plus c by completing the square. But there's no numbers, so I'm really confused.
So
fun. Okay.
So ax squared plus bx plus b over 2 squared plus c.
Right? Yeah. Okay. I got that. I get that. Now what?
Why does it say another computer's using a printer? Computer on, please. The printer. Why isn't it working?
Yeah. You look?
No, I mean, I know it's in here somewhere.
In the book?
Yeah. I see it.
I don't understand how you're supposed to find anything when there's no numbers.
I don't understand the question too. Then I had to do anything in the function to use rational zeros to.
Did you get?
Now you gotta make f of x equal 0.
What?
You just gotta make f of x 0. Right?
I don't know.
Rational zero theorem is yeah, AB has to equal 0. So
Is that the one we just did where we use the synthetic division, or is this a different one?
that's a different one.
This is different, I think.
Oh, then this just needs to be factored?
Pretty much. And so when we factor it, just like how we were doing it for like at the beginning when we were factoring completing the square and everything, like we just got like two parentheses x minus or plus b whatever it was, and then of course plus c whatever that was.
Mm-hmm.
So that's pretty much what this is saying, is that that's that. So if we know that b is like b over 2, then it's just like ax plus b over 2 squared plus c equals y. And that's the most simplest form that I can find. Unless it's in the book.
What does it say?
Y equals parentheses ax plus b over 2 and parentheses squared plus c. I have a feeling that A is supposed to go out.
Yeah, you want outside of it.
But that would,
Yes.
that would make it'd be like ABX
Well, that's why that's what I was
or
thinking.
AX. I mean, sorry, AB. So it would make BX. So you can factor out the X. That would work. The X is what's common.
Y equals x. C's x. Then we couldn't square it.
A plus B over 2 squared.
Then we couldn't have it squared. It need to be squared.
Well, X is squared.
E.
Is that the book says? What does it say?
So it just says that like x squared plus bx plus parentheses b over 2 squared is equal to x plus b over 2, both the whole thing in parentheses squared.
X
So-
plus B over 2?
Yeah, because when you complete the square and you shrink it down to like parentheses squared, it's just b over
Where does
2.
this come from?
It's just like the quotient that sometimes is minus. So like 2, that would factor out.
So y equals parentheses x plus b over 2.
Where?
All like x plus b all is over 2.
No.
Oh.
X plus b over 2.
Plus c. Okay.
Find x intercepts. That's the stinky part.
So the rational zeros theorem. Is that where it's just like one of the parentheses equals 0 equals 0 or something like we just did? With the synthetic stuff.
Hang on, rational roots.
Yes.
Rational roots theorem. Rational zeros.
So this is something factor or something.
Wait. So it is the exact same we just did.
It is?
Yeah. Find all possible rational zeros of the polynomial function. Yeah, it's the exact same thing.
But is there do we have to do anything before? You just said make the y equals 0?
X because we're finding the y.
No, we're finding an x.
Oh, well, I did part B then. So then, yes, finding the x-intercept, we make y equals 0.
Yeah, okay. We're working like number 1 and 2 at the same time right now.
Well, no, there's just 2 parts in one.
Okay.
So I was just working on what is the y
Oh, I
intercept.
didn't even see that.
Okay.
I'm sorry.
So that's what I thought we were doing.
What is
Yeah, so like he's already talking about number 2, and I was like, I didn't know the answer for A yet. Number 1. It's like, what are the x-intercepts then for A? So we completed the square, but what are the x-intercepts?
For number 2, part A?
For number 1, part A.
Oh.
Just find x-intercepts for the quadratic equation by completing the square.
That means saying 0 is y. So
That's what's kind of dumb about it. So you got minus c
yeah, minus c equals
over a square root of minus c over a. So I mean, we have an I plus or minus I c over a squared of c over a. We got
so
minus b over 2.
Yeah, plus or minus.
Minus b over 2 plus or minus I square root of c over a. Okay.
c over a.
Yeah. So you gotta put c the other side first, and then you divide it by a.
Oh, okay.
Okay, that wasn't too bad. I don't know why my stupid printer's not working. Get your stuff written down.
We can just print it later and write it down.
Okay. It's not due till tomorrow, so. Yeah, so yeah, that's our intercepts is
plus
plus or minus b over 2 plus I. And then, no, so gotta make 2 separate. Because it's x-intercepts, so it's plus I squared c over a, and then minus I. Just by then 2 of them.
So then part B is just putting x as 0.
Yep.
And so then first you want to square it. So then 0 squared is 0. And then b over 2 squared is, well, b squared over 4, right?
Yeah.
Okay. So then you factor a into quotient, so then a times 0 is 0, 0.
And it's just c.
Yeah, and plus b. Yeah. We don't even do it. We don't even touch it.
Yeah.
So then a is b squared over 4 is ab squared over.
Okay. I have to go to work. I'm sorry.
It's all good.
I'll keep working on them and talk about my answers later, I guess.
So then y equals
Just c.
no, not
Oh,
just
y-intercept is 0c.
no, y equals 0 plus ab squared over 4a plus c.
So yeah. Wait, what? For the y-intercept?
Yeah, the y-intercept is ab squared over 4a plus c.
No. Because if the y-intercept is where x is 0, so you make
Yeah.
x equals 0 on that.
Yeah,
A times 0 is 0.
yeah.
Plus b times 0 is 0. So just leave c. Y equals c.
But a is not 0. A is a.
Yeah, but it's multiplying by x, which is equal to 0. Anything times 0 is 0.
Oh, so.
So we're finding
Wait,
the place
can I see
where.
your equation that you're working with?
Yeah, so I'm just going off the original equation.
Oh, you're just going off by that. Oh, okay.
Yeah, because it's just a y-intercept of it.
Yeah.
So.
Yeah, of course. Oh, that makes sense. So I took the other one. I took
Our
the other, like the vertex.
our completing the square one.
Yeah,
Yeah.
I took that one. Okay, well, yep, touche. Show the work for that one.
It's like you're making this way too difficult. Oh, finally. You stupid thing.
Okay. Well, then number 2, what needs to be done with the function? With all that, before you can use the rational theories to find x intercepts.
That's what I don't understand.
Does x need to be factored out? X needs to be factored out. Nope.
Does it? I don't.
No, if we just need to like have another number, we need to like complete the square. Well, that's annoying.
That's what doesn't make sense, because for the rational zero theorem, all it does is take the last number. It's just the same as rational zero or rational. Whatchamacallit? Root.
Let me see if there's an equation.
So I was looking at it here in the book.
Yes.
For rational zeros theorem, it just has the equation, and then it just takes 6 and 2. It's just exactly what we did on that last one.
Yeah.
So I don't know what you need to do before.
But look, the 6 and the 8 don't have any x's on it. While this equation that's on the quiz, it stops at 15x. So we need like another quotient.
That's annoying.
Yeah, because I have no idea what B is.
Is there one that's like that we can? Where's the definition of the rational zeros theorem? I'll read that.
Well, I was there, but then I went back to chapter 1. So.
Right. Rational zero theorem. Well, that doesn't help me at all. A n x n plus a n minus 1 x n minus 1 is a polynomial function. Integral coefficients a n is not equal to 0 and a o is not equal to 0 and pq. Okay, so yeah, that cannot be 0. What do we do with that equals 0 then? It doesn't really tell us what to do if that equals 0. If p, no, not if p equals 0. That's annoying as heck. What needs to be done to the function f of x equals 2x to the fourth minus x to the third plus. Does it want us to actually do it, or does it want us to tell it what we're supposed to do?
I won't tell it.
Yeah.
But then it does say find all the real and imaginary zeros for the function, and it's the
That's
same
true.
thing.
That's true. It doesn't tell us in the book what to do with. The last one is 0.
I think I found it.
Did you?
It's on like 3.3, theory of equations and everything. The en route theorem, if p, wait, I'm just kidding. Because that's talking about something else, like where you like factor out and then you put like each of the x plus whatever's into equals 0.
Are we supposed to do the quiz on GHOA? On the group hangout? Okay. I don't know. I don't know why. It makes sense because she has no time to watch a 2-hour long group study session.
0 for number 2. It's not in the book. Let's see. Yep, I'm at a loss.
Yeah, none of the examples in here use rational zero theorem to find out possible rational zeros. None of them have n just an x. There's got to be like an easier way to figure this out. Is there a way to complete the square or something on an equation like that?
Well, what I'm gonna do is like take the first two and take that out, and then leave like 6x squared minus 15x, and then complete that square. So if we take like x squared out from like the 2x to the fourth minus x negative 5x to the third, you complete the square by that, because then it'll be like 2x squared minus 5x.
Yeah, let's just go with that.
Okay.
So what needs to be done? We need to complete the square of 6x squared minus 15x.
Okay.
Do we take the 6 out first, or do we complete the square and then take the 6 out? Take the 6 out first.
Oh yeah, no, I see what you're saying. Yep.
Yeah. Minus 15 or 6x. So we got yeah. Divide in half is just just 30 over 6. And 15, 6, divided in half. Yeah.
Because
Doesn't make sense.
you divide by 2, 15 divided by 2, but it's just squared. So then 15 squared is 225, and then 2 squared is 4.
Wait, don't we cut 15, 6 in half and then square it? Find the complete the square.
Isn't it 15? Is B? You took out 6. Oh, wait, no, I'm doing this all wrong.
Yeah, I know. Doing math for 2 hours gets to you like that. So we go, yeah, minus 15 over 6 divided by 2, or divided by half, that just means it's 5. Then square is 25. Plus 25. And do we We got a minus 25. Multiply that by 6. So 150. That's 150. That's what makes it hard, is that zeros on that. So it makes it 6. Minus 5. That doesn't make sense.
Like a complete loss right now.
Me too. Oh. Okay. I'm an idiot. Put that wrong. So I was dividing it by half instead of dividing by 2. Like a freaking dummy. This makes it 15/12. 15 divided by 12. Squared. It's a weird number. Or 12 squared. Oh.
Okay. 2x to the 4th minus 5x cubed plus 56x squared minus 15x plus 350.
Wait, how'd you get that?
There's all my work.
Okay.
Which then, what are we doing again? We are finding the rational zeros theorem. Find all the real and imaginary zeros for the function. Okay, well then, there's a lot of them. Because then P is 350 and Q is 2.
$350, huh?
Mm-hmm.
1, 2, 5, 7.
Yeah, and then whenever the 2 is
1 and 2.
One, 2.
I don't think there's that much stuff that goes with 350 though.
No.
1, 2,
2,
5, 7.
10, 7.
$50. Well, 25 goes into it. $35, 25, 35, 50, 70. $175.
And 35 and 7 is 75 is 70. 35 and 50, 70, 75, and 50. Ta-da. 1, 2. Come on. Holy smokes.
Okay. Alrighty then.
So then it's on the top we have 1, 2, 5, 7, 10, 14, 25, 35, 50, 70, 175, and 350.
Great.
Yeah. Awesome.
So go synthetic division, I guess.
Yes,
I
sir.
got 2. What do you have?
So I have 1 over 1, 1/2.
I mean, for the synthetic division, for up
So
top.
then it's 2, 5, 56, -15, and 350.
So it's just regular 5, not -5.
Oh, it's -5.
Okay, -5. All right. So let's try 1.
Good idea.
3, 3, 3, 3. No. Not even close. Like 302. Very end.
Well, then 1/2.
Try 5.
2, 1.
81.
Holy smokes, no.
It's not 5.
Not 1/2.
2. Try 2.
I'll try 7. Oh,
Nope. It's not 2. 5 halves.
it's not 7.
6. Could be a negative too. Could try a couple negatives. I'm ended up with positives every time.
I can go for -7. Let's try that. 17.
Yeah, it's got to be a negative. Jeez. These quizzes are like freaking hard.
Yeah, it is. No. No. I'm sorry. I don't know what all the imaginary numbers are. I got to that far and I'm not going any further. It's not working.
Yeah, this is.
I mean, unless if I did something completely wrong. But
I don't see how we'd get any imaginary numbers out of what we got right here.
So then number 3. Explain the difference, if there is one, between x-intercepts, roots, zeros, and factors. I'm going to use definition
Okay.
and sample stress. Center in your explanation.
Roots. See, are they just possible zeros?
Yeah. X-intercepts, zeros, and factors.
X-intercepts are where the function lines cross the x-axis.
Yeah.
Roots are the possible zeros for the function.
Mm-hmm. Zeros. Well, aren't they zeros?
Are the actual
Zeros.
are the actual places where the x or y intercepts are, right?
Yeah. And the factors are just the possible numbers that can be like crossed at like any of the x or y axis.
Factors and roots. Are factors a step before you get a root? Or are factors and roots basically the same thing?
I think the first. Yeah, I think the first. Okay.
I think I don't know if we should meet up again and try to figure out number 2 before it's all due or what. But
Well, I'm leaving tomorrow morning.
yeah, are you? Right, you are. We're at conference. Huh. I'm gone until 1 o'clock tonight.
I'll be up by then. I'll still be up.
Yeah.
I was up until like 2 o'clock this morning.
Yeah, I need to do better at studying this stuff. Try to understand it all before a group meeting. That way we don't fry our brains trying to help each other understand it. All right. Bye-bye.